All right, guys, so this is the last part. I'm going to start with question 25. Um, so right here, you are required to answer every single thing individually, which is okay. So first, we're going to look at if it's an odd or even function, okay? So looking at if it's an odd, even function, we're going to look at their footsies. So our feet look like are going in an opposite direction, which will right there tell me that this is an odd function. So again, feet are incredibly important. Okay, so let me move that to the side. So feet are very important. Okay, so they're going in the opposite direction, which makes this function odd. And then the footsie on the right side, it's negative, not positive, negative, which also tells me that it is going to be a negative leading coefficient. So right there, this footsie right here makes a huge difference. All right, now because this is the right side, a positive side right here, I know that a footsie is going down because my leading coefficient is negative. I also know that this is an odd function, so the other footsie has to go in the opposite direction, which is positive, which is also true right here. Now, roots and multiplicities. Roots means what are the x-intercepts, okay? So x-intercepts right here, it's at x equals -2. And then right here at x equals 1. Now, what is a multiplicity? It means the shape of the function right here. And how many answers are in the 1. So right here at x equals -2, I have a bounce. A bounce represents multiplicity of 2. That means there's 2 answers in there. Now at 1, it looks like a slide. And slide, it's also called intersect. You get 3 answers in there. So multiplicity is 3. So now I can say the degree of this function, it's adding the 2 plus 3. So if there's 2 there and 3 there, together there's 5 x-intercepts, 5 zeros. Now, equation in a factor form. So my x-intercept, it's x equals -2 and x equals 1. To get it to be in the factor form, I'm going to do the opposite and move the 2 to the other side by adding it. So this is going to be plus 2 equals 0. Here I'm going to subtract the 1 to the other side. So again, x minus 1 equals 0. So that's factor form. So now I can put it into my parentheses. Okay. And of course, the multiplicity, which were the numbers that we set. So for x equals -2, the multiplicity was a bounce. And for x equals 1, the multiplicity was a slide. Okay? All right. So moving on to the next question. All right, we got question 26 and question part 1 and part 2. All right, so here it's talking about the following functions for part 1 and part 2. Your function is x minus 5, x plus 3, and x minus 1 squared. So it's asking you to find the correct statement, the degree, and then the number of unique zeros. So unique zeros are going to be not the multiplicity zeros. It's just going to be the zeros, like the actual x-intercepts, okay? So that's what unique zeros means. But let's check the degree. So we're going to look at the function right here. We're going to say, okay, there is 1 there, there is 1 there, and there is 2 there. So when it's not written, the multiplicity is assumed to be 1. So that means that there is 1 answer of x minus 5. There is 1 answer of x plus 3, and there is 2 answers of x minus 1. That makes it 4. So the degree is going to be 4, so it's not going to be B, and it's not going to be D. Now the unique zeros is not 4 zeros. It's going to be exactly what you see. What are your x-intercepts? My x-intercept is 5. My x-intercept is -3. Okay. And my x-intercept is +1. So how many zeros is that? 3. Unique zeros are the exact ones that you're going to see on decimals, not the multiplicity ones. So the correct answer is C for this question. Okay? All right. Moving forward to the next one. The part 2 of that. Now we are trying to figure out the end behavior. Now, if I look for a degree, I know that I got one answer, two answers, and then 3 and 4. So the degree, it's number 4 because I'm adding the multiplicities together. So I got 1 here, and 2 here. So 1, 2, 3, 4. Degree, it's 4. 4 means an even function. So that also means that both ends are going to go either up or down. So as you are looking, it's not it because they ends go in the opposite direction. How do I know that? Because I'm going to look at the footsies. Negative, positive. Nope. B could be correct. Nope. Positive, negative. No. C is positive, positive, and D, it's negative and negative, okay? So it could be either C or D. Now let's see, it's going to depend on the leading coefficient. So leading coefficient of the function, it's positive. So that means that my footsie here is going to end this way, which means both footsies have to go positive because I have a positive leading coefficient and an even function. Okay, so even function means footsie is going to go in the same direction and it's going to up to a leading coefficient if it's going to go up or down. So that means both ends are going to go up, which means the correct answer is C. Now you are welcome to graph this and check it on the graph and look at it as well. All right, moving forward to the next question. All right, list the zeros and their multiplicities of this polynomial function. So first we got 3 in the front. We're going to equal that to 0. Next we got x plus 2, and we're going to equal that to 0. Then we got x minus 1. We're going to equal that to 0. So we take each parenthesis and we equal them to 0. And then we got x minus 5. We're going to equal them to 0. So x equals 3. It's not a true statement, so that will go away. Here we're going to move the 2 to the other side. So x will equal the opposite, negative 2. Here, we're going to move that 1 to the other side by the opposite of negative, which is positive. So x will equal 1. And here we are going to move the 5 to the other side. So x equals 5. Okay, so I got all 3 unique zeros. Now I'm going to see their multiplicities. Number 4 right here, that means that the multiplicity is 4. Number 2 right here means that the multiplicity is 2. That means there's 2 of the same answers. And nothing means it's a multiplicity of 1. Okay, so that is the answer for this question. All right, moving on to the next question, which is 28. Practicing skydiver jumps from a height over and a height power fan and floats. The function h of x is shown. The height of the skydivers during the practice section. Select all the statements that apply. So let's check number 1. The maximum shows the skydiver jump from a height was 12 feet. So maximum will be the highest hump right here. And that does not show 12 feet. It shows 11. So that is not a true statement. Okay. The next one, the y-intercept shows that the skydiver jumped from 10 feet. So let's see where he jumped at first. Okay. So he starts right here. Okay. And it looks like 10 feet. So that statement is correct. The y-intercept is 10. All right, the local minimum shows that the length of the practice section was 10.5. Okay, so the minimum, let's say the local minimum shows that the length of the practice session was 10.5. That is not true. Right here, there is a minimum that shows less than that, and then there is another minimum that does show 10.5, but the lowest point right here, it's not 10.5 minutes. Okay. The x-intercept shows that the length of the practice session was 15 minutes. That would be your last point right here when it hits the ground, and it does look like it's true. It is 15 minutes. So the x-intercept, this is the only place when the function looks like it's going to touch the x-axis. It's at 15 minutes. So that is true. So answer B so far and answer C so far. And then it says at, and then the next one says at 12 minutes, the skydiver was 5 feet in the air. So let's find 12 minutes, which is right here. And then let's find how many feet was that? 5. That is also a true statement. And then lastly, Yes, a skydiver, it's 5 feet in the air in 12 minutes. Very good. And then last one's at 5 minutes. The skydiver, it's at 3 minutes in the air. So 5 minutes, he's not at 3 feet. He's at 11 feet. So that is not true. So answer B, D, and E are correct. All right, the next question talks about the two polynomial functions, and it says the two graphs determine the minimum degree and the leading coefficient. All right, so the minimum degree, we're going to find our x-intercept. So right here, this is -2. Right here, this is 1, exactly what you see. And right here, this is 3. All right, now what are the multiplicities? Means the shape. This, it's multiplicity of 2, this is multiplicity of 1, and this is multiplicity of 1. So the degree, the minimum degree would be just adding these multiplicities, so the degree would be 4. Your x-intercepts are -2, 1, and 3. And then the leading coefficient, which is going to be the ant tail of your function, it's going down. So the leading coefficient stands for LC. It's negative. Okay? And so the function could be, if I would want to make a function out of it, I would flip the sign to make it a +2, flip the sign to make it a -1, and flip the sign to make it a -3. And the multiplicities for a 2 would be 2, 1, and 1. So if I would want to write it as in a function, this would be squared because it's a bounce. This would be 1 because it's a slice. And this would be 1, it's a slice. We don't write the ones, I just wrote it visually, okay? Now pause that if you need to write that down. All right, now here I got a x equals 1, and the multiplicity seems to be 2, and 1, 2, 3, 4, x equals 4, and the multiplicity seems to be 1. So once again, x equals 1 and x equals 4. Multiplicity, it's 2 for a bounce and a 1 for a slice. Okay, my leading coefficient here is traveling, my tail, my end travels up, so my leading coefficient would be positive. Okay. And then the degree here will be 2 and 1, so degree is 3, which makes it true. This is an odd function. This is an even function with the degree 4. Okay? Now, if I want to, I would change this to x minus 1 and then x minus 4, and I would add the 2 on the top. So my function would be x minus 1 squared and x minus 4 to the first power. Okay? All right. Moving on to 31. So this is factor each expression. So because you only got 2 items here, remember that we are going to use our formula, a minus b, a square, flip the sign, a times the b plus b positive at all times, or a plus b, a square, flip the sign, a times b, always b positive square. Okay? So I am going to square root both of these numbers. Remember that x cubed is just x and 27 is just 3. Now this is a negative in between, so we're going to use the first function right here, which is this one. Okay, so we are going to use x minus 3. Then we're going to flip the sign. We're going to take the x and square it. So a, this is your a, this is your b. So it's a squared, so x squared. Flip the sign to positive. A times b means 3 times x. Okay, and then a b always positive. 3 squared, it's 9. Okay, so 3 squared. Okay. All right, for the next one, I got a positive number here. So again, I'm going to use the second equation this time. So I'm going to square root, cube root this one. I'm sorry, I meant to say cube root here. I apologize. Okay, it was a cube root, not square root. You do the opposite of the root. I meant to say cube root, but I said out loud square root. So you cube rooting these two. So cube root of 8x cubed, it's 2x. And then cube root of 1 is just 1. So again, this is your a and this is your b. You're going to use the second equation, so it's going to be 2x plus 1 now. Then you're going to square the 2x. So I'm going to write this one out. opposite sign, multiply 2x times 1, and then positive b squared, which is 1 squared. Okay? Now remember that when you square, you're going to apply this to both. And you can also use, if you have ABC answers, you can use them and check the answers to compare them in Desmos, right? Plug in the answers and plug in the question. So this is going to end up being 2x plus 1. And then here you're going to get, oopsie, here you're going to get 4x, okay, minus 2x plus 1. Now you can again use Desmos to do that. So let me show you the first one. So you got x cubed minus 27. Let's see. So we got x cubed minus 27. And now if I would write the answer, I'm just going to do the correct one. So as you can see, you got a graph here going on, okay? This graph right here. Now I'm going to plug in the answer. It was x minus 3 times x squared plus, oopsie, x squared plus 3x plus 9. As you notice, if I undo the color, it changes to a blue one. They overlap each other, as you notice. So you can play with these colors. Just want to make sure that everybody understands and compare the answers to make sure it overlaps each other, that your answer is correct, just to check it, okay? All right, moving forward, here it says for each polynomial function, identify the zeros, their multiplicities, and then sketch a graph with appropriate end behavior, okay? So here in number 33, we have a 3x. We're going to take it and equal it to 0, okay? We are going to have x plus 5 and equal it to 0. And we're going to have an x minus 2 and equal it to 0. So all of the components is of that function. So this divided by 3 is just x equals 0. And we can't dismiss that because it has an x, not just a number. Here, x will equal positive 5, and here x will equal 2. So these are my zeros. 5, it's right here, a 0, and a 2. Okay? Now, nope. I did something wrong. It's supposed to be a positive 5 here and a negative. That's why. I apologize for that. So positive 5, I wrote it out wrong, and so this would be negative 5. So right here. Okay, negative 5. All right. Now the multiplicities. The multiplicity for 3x and 0 is just simply 1 because it doesn't have anything like squared or anything. Okay, the multiplicity for x plus 5, it's 2. That means there's a bounce. And the multiplicity for negative 2, it's also 2, which is also a bounce. Okay, now a leading coefficient is very important. So I'm going to look at the front of that function, and I see it's a positive 3. That means the leading coefficient, it's positive. So that means that I am ending right here. Okay, now my degree of the function, let's count the multiplicities, a 1, a 2, and a 2. That makes it a 5. So the degree is 5, which tells me that the leading coefficient, it's positive, but the other end is going to go in the opposite direction. Okay, because it's an odd function. That's what it tells me. All right. Now, I'm going to start always from the back, from the leading coefficient. I'm going to go down to number 2. Number 2 was a bounce, so I'm going to go down and bounce it. Then 0 was a slice, and a 5 was a bounce again. Okay, so I want to make sure that this is a bounce, and this is a bounce, and this is a slide, according to my multiplicities. So this, it's a slice. This is a bounce, and this is a bounce. So I always start from the positive leading coefficient. I go backwards to my first point, which is 2. I bounce it up. Then I go up, and then you go straight through 0, and then you bounce it back down. Okay? And then that tells me that both ends end in the different direction. All right. And that would also tell me, just in case, You want to know, that will tell me that because this function it's, let me see, because on the right side here, as x approaches positive infinity, my function has a positive leading coefficient. That means if it's an odd function, the other leading coefficient will go down, which is true. So on my negative side of the function, these two need to be different because it's an odd function. So again, pause that if you need to. Write that down. All right, and for the next one, I have a -2 in the front. -2, it's not going to do anything because it doesn't have an x, and -2 does not equal 0. That's not a true statement. Then I have x plus 3 equals 0, x plus 1 equals 0, and x minus 2 equals 0. So x will equal -3, x will equal -1, and x will equal +2. Now, our multiplicities right here are going to be, at this one, I got a 2. At this one, I got a 3. And at the last one, I got a 1. And 2 doesn't have any multiplicity because it doesn't have an x. So my function is 2 plus 3, which is 5, which is 6. So my degree of the function is 6, which is even. My leading coefficient here is going to be in the front of that function, which makes it negative. So my leading coefficient is negative. So, and this is an even function. So that means my end tail ends this way. That also means that my other tail is going to also end this way because it's an even function. Now I'm going to have the zeros. I'm going to plug them in. So I got -3 here. I got a -1 here. And I got a 2. Okay. So that means if I am starting from the right side, and let me make it red. Okay. If I'm starting from the right side right here, negative leading coefficient. If I'm going through 2, I'm in slicing through because that's what it says, a slice. Then I'm going to come back down and I'm going to slide through -1. Then I'm going to go back up and bounce through 3. Okay, because this is a slide and this is, or intersection, and this is a bounce, and I'm going to meet the other end. So then in this case, both ends goes down. So it doesn't matter if I am on the right side or the left side, my f of x goes up, down, and my f of x goes down. Both footsies are going to go down. So both of them right here are going down. All right, question 35 talks about Angie has a space to plant at the most 25 tomatoes and pepper plants in her garden. Tomato plants cost $5 each, and a pepper plant costs $10 each. Okay, and which of the following? And Angie must spend less than $200 on plants, not $200 and less than 200. Okay, which of the following combination would be feasible? Feasible means it will fit. It would make it work. All right, so what I did was I created 2 equations, okay? One equation, 2 constraints. One equation was x stands for tomatoes and, x stands for tomatoes and y stands for peppers, okay? And then I created an equation, x plus y has to be less than 25. And then, because it says that Angie has a spade plants at most 25 tomatoes and peppers together, right? So if I do X for tomatoes and Y for peppers, she can't have more than 25 of both. And then I made a second equation constraints where it says 5X, which means $5 for her peppers plants. Hold on, $5 for peppers. So that's backwards, I think. And oh no, tomatoes plants $5. So 5 times X plus $10 for peppers. Okay, which is why she can't spend more than 200. All right, so I made it less than, not less than or equal to. Okay, because she can't have more than 200. And then I use these points right here. So 30 and 5, 0 and 20, 10 and 15, and 12 and 12. And I plugged it into the second equation, which is this one right here. Because I want to make sure that, you know, it's less than $200. So she spends less than $200. Okay. All right. So first one, 30 and 5, kind of always doesn't make sense because 30 and 5, it's not even gonna reach. It's gonna be too much. It's gonna be 35 plants. So A could not be true. And then we can also plug it in here. So 5 times 30 plus 10 times 5. This is gonna be way too much. It's gonna be more than $200, right? So that would be 300 plus 50, so 350. So that would not work. Now the next point, I would say 5 times 0. Well, first of all, 20 and 0 will go under 25. But let's check. So 5 times 0 plus 20, 10 times 20. Well, that makes it 200. So that's 200 less than 200. It's not less than or equal to, so we couldn't use this point either because this is 200 has to be less than 200, and it's not. So we couldn't use B either. All right, C, let's see. 10 plus 15 will make it equal to 25. So let's see if that works. So we have 5 times 10. So I'm doing this point right here. And then plus 10 times 15. So that one, so 5 times 10 plus, okay, so that would be also, I don't think this would be true. So let's see. So that's 50 plus 150. Okay, so 200. So then once again, that's 200 less than 200. I don't have an equal sign here, so this is not a true statement either. So this could not be it. And then the last thing, you got 12 and 12, so 5 times 12. So 12 is 12, it's under 25, which is good. And then 5 times 12 plus 10 times 12. Let's see if it's going to be less than 200. So this is going to be, let's see, 180 less than 200. So the last answer, D, it's the correct combination of 0.12 and 12 because that's $180, which is less than 200. So feasible means it would be in a gray area. Now, you could also have checked that if you don't want to do all these calculations and do 5x plus 10y. Let's see. 5x. There was another way to check it. 5x plus 10y, it's less than 200. Okay? And you could have found the points, right? So the first point we had was 35. Okay? So that point is on the line right here. And we can't have it on the line because this is a dotted line. It means the point is not included. So this could have not been it. Then we could have do 0 tomatoes. So again, plug the point 0 tomatoes and 20 peppers. Another point that is also on the line we could not use because 200 has to be under. Then we had 10 tomatoes. And then we had 15 peppers. Another point that's on the line, also not in a graded gray area, and it doesn't belong. And then the last one was 12, 12. Once again, this one is in the gray, in a shaded area, which means it's feasible, which means it does fit, it belongs, right? It's in the solution area. All right. And then the next question right here is 36. All right, so here we're talking about a baker. It's selling 2 types of donuts, the glazed donuts for G and J for jelly. All right, and the customer wants to buy no more than dozen. So no more than dozen, okay, which means it includes the 12. And it wants to try at least one of each kind. So at least one would be more and greater than one, more and greater than one. Okay, so at least one. So one and more of the glaze and of the jelly. So right here, we have to be less than 12. So this answer not correct, this answer not correct. And then you have between 0 donuts and at least one. So obviously the answer would be A. Okay. All right, so craft toy wagons are made to sell at a craft fair. It takes 4 hours to make a small wagon and six, which represented by an X. And so this is small. Let's name it because the answers are in opposite order. You start with large and you go with small, which you will think it's X and a Y, but it's Y and an X. So this is your Y and this is your X. And then 6 hours to make the large wagon. So this is a Y. Okay. So 4 hours for X and 4 small. Okay. And 6 for large, which is Y. Okay. All right. Now, it says the owner has no more than 60 hours available to make the wagon, that wants to have at least 6 small wagons to sell. All right. So 6 small wagons to sell. So we are going to look at the area, where we talk about, 6 large and 4 small. Okay, so we're gonna look at each answer. So at least 6 small wagons. So at least, so it's gonna be here. So the area of at least 6 more wagons is gonna go to the right, right? So it's X has to be greater than 6. So that would be the area that is shaded. So now let's see which point fits in that area. So 0 large wagons and 2 small wagons. So again, remember, this is your Y and this is your X. So 0 for Y and 2 for X. So right here, let me make it red, right here. So that's a no. Okay. Then the next one is 1 large wagon. So 1 for Y and 2 for small. Also no, not in a shaded area. 4 large wagons. So we're going to say 4 and 8 small. So let's see 8 small. Let's see if they match. Yes, so this point right here, it's the point that we're looking for. So that is our feasible in our shaded area. And then let's just make sure we check 8 large wagons. So we're going to go all the way to 8 and then 6 small wagons, which is right here. So 6, 8, it will be outside right here. So that's a no either. So the only feasible point would be point C. So point that would fit in a shaded area, the part of the solution, okay? All right. The next question here is find the minimum volume of the object function. Object function means profit. So how much money am I making? And the profit function is 12x plus 20y. And now we are going to find our vertices, which means the points that make the shape, right? So the edges of the shape. So right here, it looks like I got 2, 4. The point on the bottom right here, it looks like I got 3, -4. And the point on the edge right here looks like -5 and 2. Now remember that you take these vertices, these points, and you're plugging into this equation. So 2, 4 is going to be, this is your X and this is your Y. So we're going to plug in 2 for X plus 20 and 4 for Y. So that is when we're going to get 12 times 2 and then 20 times 4. Together we're going to get 104. The next point is -5 and 2. So once again, 12 times an X, it's -5 plus 20 times 2. So we are going to get -20 here. And then the last point is going to be 3, -4. And we are going to get 12 times 3 for the X plus 20 times -4 for the Y. And we are going to get -44. So it's asking us for a minimum volume. So the minimum volume right here is going to be -44, which is the smallest out of all, right? So -44 is the most minimum volume there is. Okay? All right, moving on to the next question, question 39. So we got 2 more to go. So here it's we're going to create constraints. Okay, so here it says Molly is making chocolate chips and oat milk cookies, and then so we're going to name this X, and we're going to name oat milk cookies Y. To sell the bake set, a batch of chocolate chip cookies, and let me move that a little bit just to make sure we can see it. All right. A batch of chocolate chip cookies requires 2 eggs and 2 cup flours. Okay. Um, so 2 eggs and 2 cups flours. Okay. So you got X for chocolate chip and Y for oatmeal. Okay. And then the oatmeal cookies requires 3 cups of flour and 1 egg. So you got eggs and a flour. So we are going to use the 2 eggs for the chocolate chip with how many eggs for 1 egg for oatmeal. And the total eggs is 8. So no more than 8 eggs. Okay. So again, eggs, eggs, eggs. I understand that this is chocolate chip and this is oatmeal, but this represents eggs, and this represents eggs. So this equation is in regards of eggs. And now you got a flour. For chocolate chip cookies, we're going to use 2 cups of flour. So this is going to be 2 eggs. For oatmeal cookies, we are going to use 3 cups of flour. So this is going to be 3Y because Y represents the oatmeal cookies. And the total of cups of flour is 12. So less than 12. And of course, then we're going to have an X that's greater than 0. Y then greater than 0. Why? It's because we want to have positive quadrant in constraints. Okay. All right. And then lastly, so we're going to plug that in just a second. And then we are going to create a profit equation, which has to do with money. So we're going to find the money part into this equation. So the money part right here says the profit of 2 on both kinds of cookies. So that would mean 2x plus 2y. It's your profit, okay? So now let's go back to Desmos right here very quick. We're going to take all these away, and we're going to plug in all the 4 constraints. So we had 2x plus 1y. And that was less than or equal to 8. Then we had 2x plus 3y. And that was less than 12 cups of flour together. And then, of course, we had an x that was greater than 0 and a y that was greater than 0 to look at a net positive quadrant. Now, we're going to look at this, and we're going to say, oh, let's make it closer, okay? So what is like the most shaded area? And again, if you don't know, start from the beginning with your colors. Okay, where do they overlap each other? So right now we have the green. Then we got the purple, so that means we're going like from here to here and then down this way, right? Not down here, but down, I can't draw it, but down this way. Okay, where the arrow is showing. Now we're going to add this one and then this one. So still, the points that we are creating for the most shaded area are it's this point, and then this point right here. And of course 0, 0, but we don't count 0, 0 because that's 0 profit. So you want to make sure that it's not this point right here, that you are going from down here because that is where that line crosses right here, okay? So you got 0.4. So the points are, all right, the points are 0.4, and then you got 4.0, and then you got 3.2, I believe so. So let's look back in here. Yes, 3.2, 0.4, and 4.0. Okay, very good. Now we're going to take these points and plug it into our profit equation to see, what's going to give us the best combination. So we're going to do 0.4 first, and then we're going to plug it into this equation. So that's 2 times 0 plus 2 times 4, it's going to be 8. Then the next point is 4, so now we're doing 2 times 4. And plus 2 times 0, that's also 8. And then lastly, we're going to have the point, which is 3 and 2, which is our vertices. So 2 times 3 plus 2 times 2 is going to give us 12. So obviously, this is the best combination. This is your maximum. But what does that mean? That means as I'm looking at this point right here, and X stands for chocolate chip cookies, and Y stands for oatmeal cookies, what I am saying is that the most money I'm going to make if I have a combination of 3 chocolate chip cookies and 2 oatmeal cookies to make the profit of $12. That's what it's saying. Okay. All right. And the last question on the review, you're almost there. It says, Lachelle is taking her psychology final exam in which multiple choice questions are worth 10 points. So that's an important multiple choice and then free response and worth 15 points. So again, multiple choice will be your X and Y, it's free response. All right. So it takes 3 minutes to answer each multiple choice question and 6 minutes to answer the free response question. The total time allowed is 60 minutes. And so you got 6 minutes, 3 minutes, 60 minutes. And then it says that she will not answer more than 16 questions. Okay. So question. So we're going to start with multiple choice and free response. She cannot answer more than 16 questions. Okay. The next one is going to do something to do with minutes. All right. So 3 minutes was for multiple choice, which represents our X, and 6 minutes was for free response, which represents our Y. And the total amount of minutes was 60. So minutes. Okay. So this is all minutes. Okay. And then, of course, our objective function would be the points, right? And again, it will throw you off because it starts with the points. So the question would be 10 points. Okay, so you would have, oopsie, I apologize for that. You would have multiple choice question are worth 10 points, so 10x plus, and a free response question is worth 15 points. And we're trying to figure it out. Assuming all answers are correct, how many items of each type should she answer to get the highest score? So we are going to, again, get x greater than 0 and y greater than 0 and figure it out. What are the points? And then plug them in to see. So let's go back to Desmos very quick. So we're going to keep the y and the x greater than 0. So we had multiple choice plus free response has to be less than 16 questions. Oops. And then the next one was 3 minutes for multiple choice plus 6 minutes for free response, no more than 60 minutes. All right, so once again, you have to kind of zoom it out to see what's going on. And again, if you don't understand what's happening right now, this triangle is the most shaded area. When I add the blue, which overlaps, is going to be this point, and then back down to this point right here. Because only this triangle was covered for all. So the 3 points are going to be 0, 10, 12, 4, and 16, 0. So let me extend my page here. All right, so the 3 points are 0, 10. I got 12, 4, and 16, 0. This is 4. All right, so we're going to plug that into our equation. So 10 times 0 plus 15 times 10, that equals 150. Next one would be 10 times 12. Okay, plus 15 times 4 will equal 180. And lastly, you're going to get 16 times, oops, sorry about that, 10 times 16 plus 15 times 0, and that's going to give you 160. So the maximum amount of points is obviously 180. It's your maximum. So what does that represent? X and Y. So that would represent 12 multiple. So to get the highest score, she would have to have 12 multiple choice questions, because that's what X was represented, and 4 free response to get a maximum of 180 points. Okay, that's all. Thank you.